What do we think, Max? We want to go ahead and get started?
I'm ready, Peregrine.
Yeah, I'm ready too. All right, a wave to everyone, and we will get started. Welcome to Little Lab at Home. We are going to be starting our really exciting series on prehistoric times. We're calling it Lab Before Time. And I'm really excited for that one because I'm really interested in things that happened before us, way, way, way before us. Thank you for introducing Bagel in the chat, by the way. Hi, Bagel. I love when Bagel comes to our programs. So we're going to be talking about a really interesting topic today. We're going to be I'm at least going to be getting my hands dirty, and I would love to hear from all of you in the chat as you're able, but also Max and I will just kind of be talking. And we're talking about kind of the very beginnings of life on Earth. So we need to go back in time in our brains. Let's go back in time, not 100 years, not 1,000 years, not 10,000 or 100,000 or even 1,000,000 years. We're talking about going back in time around 3.5 billion years to when scientists date kind of the oldest kind of fossils of life that they've been able to find. And the oldest fossils of life that we've been able to find are a type of life called bacteria. I was wondering if all of you might tell me what you know about bacteria, or what does it make you think of? What do we think? Because we're going to be talking a lot about bacteria. It's very important in our lives today, and certainly it was very, very important long ago.
Are bacteria big or are they small?
Ooh, what do we think? We think bacteria are big, or are they very small? What do you think, Max? I think that bacteria are pretty small. Oh, exactly. My friend here says, yes, bacteria are small. They're so small we can't even really see them unless there's a whole bunch of them, right?
Okay.
But they do really important jobs. They're really important for all life on Earth, including our lives. And when we're talking about bacteria and how bacteria formed way back in time, right? We don't exactly know, right? Because even though we have a time machine in our brains, we don't have a real time machine. We can't really go back in time, and we can't know for sure exactly how the first life started. We do know that if you take a lot of the chemicals that we found in the early Earth's atmosphere and you add them together with an energy source, you can create some of these teeny tiny pieces that things are made out of. You can make little molecules that make up bacteria. We haven't gotten from the molecules to the bacteria part on our own yet. We're not super good at making things from scratch that well yet, but we are going to be cultivating some bacteria today and just kind of looking at an entire tiny ecosystem. And this is a really good addition in the chat that some bacteria can be dangerous and some can be useful. That's a great point. Right? There's some bacteria that can make us sick. There's some bacteria that we need or we will get sick if we don't have it, right? So it does all these different jobs. And so what we're going to do today is we're not going to make real primordial soup. We're not really going to make life from nothing, right? We're not able to do that. But we are going to take some different ingredients that life loves, and we're going to put them together into kind of our own little experimental chamber where we can watch them grow. This is going to be called a Vinogradsky column, named after the scientist who first observed them. So I don't know if any of you are doing the experiment along with us today, but I know I will be getting my hands dirty, so I've got towel to wipe my hands on. I've also got my column or my jar. You can also use something like a water bottle with the top cut off. You could use, right, like a soda bottle, anything that's clear so that we can see what's going on inside of it and so that also the sun can get in. I've also got plenty of dirt So I got this dirt by the banks of Ellerby Creek at the museum. So I've got some of this nice dirt from outside. It's got a whole bunch of stuff in it, some sand, it's got some pine needles in it. That's okay, it might even be useful. I've also got some water that I got from Ellerby Creek. So we can see this is some Ellerby Creek water. You can also use water from the sink as long as we leave it out for a while so that all of the chlorine can kind of get out. If we have water that we let sit out for a while, that will also work. But rainwater will work, any kind of pond water, puddle water, anything like that is perfect. So I've got a few other ingredients too, and these are going to serve kind of like food for these little bacteria. I've got some Epsom salt right here, which can be used as a couple different things, but it's also really useful as a fertilizer. It's got something in it. It has magnesium sulfate. So it has sulfur in it, which is something we need. This is why sometimes instead of using Epsom salt, people could use like an egg yolk is a really good source of sulfur. Plaster of Paris is another good source. And then I need to put some carbon in there. It's just another one of my ingredients. I'm going to be using a little bit of cornstarch. And then I thought I might also add a little bit of baking soda because I heard that I could use this. But other things that will work as a carbon source for me: pine needles, dead leaves, a little bit of paper towel. We're talking about just putting all of the things in our jar that the bacteria need for them to live, for them to eat, and for them to live together. So now we finally get to my favorite part of this experiment, which is where I get to get my hands dirty. So Max, I'm going to switch to experiment cam.
Love it, Peregrine. I'm excited to see you do this. And while you are preparing your Vinogradsky column, let's talk a little bit about just some of the learning outcomes for this particular experiment, right? Because what you're doing, I think, is so exciting, not only in that you will perhaps get to see a really, really interesting scientific process happen in front of you, but this is also really important early science process skills, right? And one in particular that I love is that this is a really good way to practice an important scientific principle, and that one is patience. Patience is really, really important for this experiment because you're not going to add in all of these ingredients and see something happen right then and there. And I think that Peregrine starting this experiment will show us that. Like Peregrine told us at the beginning, life isn't just going to start in there. What's going to happen is there's one last ingredient that we won't have time to add in during our little lab experiment today, and that's time. We need to give it a little bit of time, and while we're giving it that time, we also have, along with that scientific skill of patience, the skill building of observation. We get to watch things begin to change inside of our experiment. All right, Peregrine, go ahead and get started.
That's a great addition. I like that. We're going to need some patience, and we're going to need to be able to observe this over time. We're going to start actually with our paper towel, and this paper towel isn't just for cleaning up messes. What we're going to do is we're going to rip it up into smaller pieces. And this ingredient is going to be kind of like food for some different kinds of bacteria. We know that paper, including newspaper or paper towel like this, is made from plants, and it has plant fibers called cellulose in them. So I'm just going to rip up a little bit of my paper towel, maybe about half of it.
Peregrine, I love that this also gets to think about things as being the sum of their parts, that all of this stuff that we use actually comes from a lot of different things sort of mashed together and given a little bit of time and process. And I think that that's another really important science process skill, to think about things as being mixtures of a bunch of different stuff.
That's true. Things are rarely made out of just one thing, and this is going to be made out of a lot of things. So we've got a little bit of paper towel here, and I'm going to start by adding a little bit of my water to this mixture because I want to make sure that my paper towel is nice and wet. I don't have to put a lot in, right? We're saying just a little bit. And I'm going to use my spoon, or I could also use my hand, but I'm going to use my spoon for this one. Stir it around a little bit. Get these nice and wet. And now I'm going to be adding my dirt ingredient from my bucket here. So I can use my spoon to scoop. I can also use my hand to scoop. I'm going to use my hand to mix it up. I don't know about you guys, but my dirt is a little bit clumpy. There's a lot of different things inside of my dirt. It's not very smooth. So what I'm going to do is, oh, I even see a little ant in here. I'll see if I can get him out. Oh, all right, we rescued the ant. We've got kind of this mixture of dirt and water now. What I'm going to do is add a little bit more water. And now I'm going to use my hands to mix this up. What we're going to do is stick our hands right in and start kind of smushing it up like this. I really like this feeling. I don't know about you, Max, but I love the feeling of breaking up. Here's like a piece of, looks like clay that I could use my hands to break up.
Well, and you know what? Oh, go for it, Peregrine.
No, go right ahead.
I was just going to say, along with it feeling cool, breaking up stuff with your hands like that is another really important tactile skill. You're building fine and gross motor skills. And I would also add that what you just did, the use of a tool to sort of scoop and to pour, those are also really important uses of tools and help especially very young children get used to simple actions like pouring and measuring and using common tools like spoons or scoops or things like that. So I love that you're getting dirty, because I'm sure that you're going to mention this later on, but science is kind of a dirty process, and it's important to literally sometimes go in and get your hands dirty like you are right now.
That's very true. A lot of times we think about science being done under very, very clean or sterile conditions, and sometimes they are, but this one is a nice and messy condition. So I'm gonna say, now I could just say, here's my column and I'm starting out, but I'm gonna just put it in my bigger column here, my bigger jar, so that we can see it. And I can use my spoon to help pour. I can use my hands to pour it in there. I'm gonna scoop what I've got in here. All of the paper towel in there. I'm putting the mud in there. I'm putting the water in there. And I'm going to mush it down a little bit. And now I'm going to add my different my different ingredients. So I'm going to take a little bit of this Epsom salt, or you might be using an egg yolk. That's a really common one. I'm just going to pour a little bit of it in here, about like that. So if I were using a spoon, this might be something like 3 or 4 spoonfuls. The great thing about this is it's hard to add kind of too much or too little, as long as we're not filling the whole thing up with Epsom salts, right? Different amounts of these different ingredients might give us some really interesting results. So I'm stirring this in pretty well here. That'll be the source of sulfur for some of these bacteria. I'm going to add a little bit of the cornstarch, probably about the same. This is maybe about 1 big spoonful of that cornstarch. I'm stirring it in, and this is a pretty strange concoction, I think, but it's getting very smooth. I noticed that it's very, it looks exactly like mud, which is perfect. So I've created about this much. I could add a little bit more if I want to, but I think what I want to do now is put in the rest of my water. We want to have a little bit more water on top because it does a really important job. So right now we look like we just have a bunch of, oh, here we go. Looks like we just have a bunch of soil and bits of paper towel and water. But in here, there are a lot of different bacteria living inside of here, right? And we've created a really good environment for them to all live together. What we've done is by putting the water in here, we've limited the amount of air that can get down, especially here at the bottom. That means that the types of bacteria that are really good at growing without oxygen will tend to grow lower down in our column. Whereas the different bacteria that like a little bit more oxygen, that also need more light, will be able to grow up here at the top. And over time, this can create a really, really interesting effect. I wanted to look really quickly at just a cool picture that someone has made of a Vinogradsky column after a couple of weeks. So here's one example. You can see how there's a different color on top than there is on the bottom. You might notice cool things like little lines in there, little squiggles. You might notice little clumps, right? There's all sorts of different things in there. And it's just that a little bit of time takes bottles like these, right? That look kind of like ours with water on the top and soil and stuff in the bottom, and turn them into beautiful, almost works of art because of the different bacteria that like to live inside of them. Those bacteria can be different colors, they can be different textures. The ones on the bottom often tend to be red or purple because they like to eat sulfur, some of those ingredients that we put in there. And the ones on the top are often very green. And I was thinking maybe, Max, you could tell us a little bit about the green stuff on top.
Well, that gets back to why we're calling this a lab before time, and what all of this has to do with thinking about deep time, time that's so far away that it's kind of hard to think about. So billions and billions of years ago. Because that long ago, all life on Earth was teeny tiny. We were talking earlier about bacteria being so small that you can't see it. But billions of years ago, the only life that lived here was that small or smaller. And another big difference on Earth was that the atmosphere was very different than how it is now. And those two things are related. It means that those two things have to do with each other. So the very first thing I want us to do, and Peregrine, you might want to do this away from your primordial soup here, is let's all take a deep breath, right? Ready? 3, 2, 1. So when you breathe in on Earth here today, you're breathing in a few different chemicals, nitrogen being the one that you're breathing in the most of. But one really important thing that you're breathing in is, if you know it, you can put it in the chat there. You're, of course, breathing in oxygen. Thank you so much. You're breathing in oxygen, which is really important for us and for a lot of other life forms here on Earth that require that to survive. A long time ago, billions of years ago, when the only life were these teeny tiny little things, there was not very much oxygen around in the atmosphere on Earth. But along came that odd little green, teeny tiny little organism called cyanobacteria, which you might be able to find at the top of your Vinogradsky column in just a few days. So given a little bit of that last ingredient, time, you might be able to see, and I bet you will be able to see, some of that cyanobacteria. I've got some here in some water that I took from a plant here in my house earlier, and I actually have a little Vinogradsky column inside of my terrarium here. You can see some of those layers there towards the bottom. And some of that really nice green stuff near the top, that piece of that column, that's cyanobacteria. It's an algae that also has a symbiotic relationship with bacteria also. And the important thing about cyanobacteria is a long time ago, when cyanobacteria came to emerge in the oceans on Earth, cyanobacteria started to produce a lot of oxygen. It started to photosynthesize. And so this atmosphere that all of these different teeny tiny little organisms were living in, that they loved because it didn't have very much oxygen in it, suddenly cyanobacteria started pouring oxygen into the atmosphere. And all of these other things that were alive, oxygen was really toxic to them. They could not survive with all of this oxygen. We call this event that happened billions of years ago the oxygen crisis, because this meant that the more cyanobacteria started growing out and the more oxygen it started putting into the atmosphere, the less these other things that were already there that couldn't live with oxygen could survive. So all of those other things started to go extinct. They started to no longer be able to survive on Earth. Now, what cyanobacteria did for us is it made an Earth that could support things that were alive that were bigger than the teeny tiny little one-celled organisms that survived back then. Cyanobacteria, on one hand, made it so that many, many, many living things went extinct, as suddenly the Earth that they lived on became totally toxic to them. On the other hand, it produced an atmosphere that we could live in, and that pretty much every other living thing on Earth that lives here today could live on too, because we rely on oxygen. So our Earth and those deep breaths that we just took, they rely on that interesting little organism that I think you might be able to see inside of your Vinogradsky column in just a few days. And I think that that is really, really interesting.
I can't wait to see it. And yeah, again, a couple days or maybe 1 or 2 weeks. The last thing we're going to do for our column is we're just going to put a little bit of clear plastic wrap on top. That might stick pretty well on its own, but you can always use a rubber band to make sure it's secure on there, and that creates kind of this little closed environment. And that's so interesting, right? The cyanobacteria that's up here will kind of create its own atmosphere that works very well for it, whereas the bacteria that don't like oxygen as much will be kind of almost like safe here at the bottom because of all of the water. So it'll be a really interesting experiment. I can't wait to see what kinds of colors I get, what kinds of patterns I get. I know it'll take time. A lot of the pictures that we looked at took like 8 weeks or more, but this is something that's really nice to have kind of in a window that I can look at maybe every morning. I'll be really interested to observe some of those changes. Yeah, now all this needs is time and a little bit of sun, right? We don't want the sun streaming into it all the time, but it getting plenty of light will help, especially that cyanobacteria grow in the top. That's the first thing I'll be looking for. Well, wonderful, my friends. I think we learned a lot about kind of how maybe life started, what life looked like at, very, very, very long ago in deep time. And we figured out a way to make our own sort of miniature environment where we can see some of the same bacteria that first existed so, so, so long ago. I hope that you will continue to observe your Vinogradsky column, easy for me to say, and we'd love to see pictures of it if you want to share them with us. If you want to take pictures of them over time, and if you post them on social media, we hope that you will tag the museum and hashtag lab at home, because we would love to see some of the things that come out of this experiment. That is all for our first episode of the series, Lab Before Time, but next time we're going to be talking about everybody's favorite dinosaurs, and specifically the sounds that dinosaurs might have made. We're going to be experimenting with sound, talking about dinosaurs. It's going to be a lot of fun. I hope that we will see you all there. Thank you so much for joining us today, my friends. We'll see you later.
Thanks.
See you later, friends.